Hey, how about a quick video on how to use your calculator to do integrals? Disclaimer right up front, I'm using a very old calculator and I don't feel like buying a new one. The method I'm going to show you is going to work, but the newer calculators have other methods to get this done. I'll show you why I still like this method the best. So we're going to do the integral of sine of x from 0 to 3. And if I do a graph of sine of x, I've marked my x-axis by units of pi. So this is 1 pi, this is 2 pi. If I'm going the integral from 0 to 3, that means I'm going to end right about there. Well, here's how you do it. I hit on my calculator the second button and then calc. And you notice that there's where your dy dx is located, where you can do a derivative value. And right beneath it is the integral. And it just asks for the lower limit of 0, asks for the upper limit of 3, and here's why I like this method. It shades for me. So it looks like it went all the way to that intercept, but it didn't because there's really a little bit of unshaded area in there. But anyway, there's the value for my integral, and I didn't have to do any of those stinking steps by hand. I'm going to do another one. I'm going to use the same function, but I'm going to go from 0 to 2 pi. I'm going to deactivate that and then reactivate it because that gets rid of the shading. And now if I go, second, trace or calc, and that gives me this menu. I want the integral, and got to wait a second for it to graph it. So with the newer calculators and other methods, you don't get the graph, and it's faster, but you don't get the picture of the shading, which sometimes helps. The newer calculators will still do this method as well. Lower limit of 0, upper limit of 2 pi, and now you should see shading go all the way from here to here. And my actual value is 0. It's right down there, so the integral value is 0, which makes sense because as much positive area was accounted for as negative area, so their sum total was 0. And I'm going to do one more. Let's do the same function one more time. And second, calc. But now instead of going to 2 pi, I'm going to go to 12 pi. So I go to my integral. Always got to wait for it to graph. Just meditate. 0 for my lower limit, 12 pi for my upper limit. Ruh-roh. So here's the thing about this method. If your limits of integration fall outside your window, and my window only went to 3 pi, then it's not going to work. So I would have to adjust my window to go greater than 12 pi. By the way, your calculator only cares that your X window is appropriate. It doesn't care about your Y window. To show you that your calculator doesn't care about your Y window, we're going to go from 0 to 1 and we're going to integrate this function. Well, when I graph this function is going to be too high on my Y window. It's going to be invisible. Let's take a look. So I hit graph, but nothing's showing up. It's because my function is living way up here. But the calculator doesn't care, just like the honey badger don't care. As long as my limits of integration are within the called on window, you see that it's shading. It's technically shading from 0 to 1 up to my function, which is living somewhere up here. I still get my answer of 7.333. So that's my advice on getting integral values with the calculator. If you want to find different methods for newer calculators or quicker methods for newer calculators, I'm sure a quick web search will get that done for you.